At the end of this exercise, you shall be able to prepare plate pieces by gas cutting and by grinding to size. Set plates as a lap joint and tack weld at both ends. Place the lap joint in a flat position for welding. Deposit root run of proper size and ensure penetration. Deposit the final covering run in the lap joint of proper leg size. Inspect the lap fillet weld for surface defects.
Now, let us see the tools required for fillet welding. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, angle iron, electrode cable and earth cable, electrode holder, electrode hand shield, marking material, personal protective equipments, SMAW welding plant machine and their setup accessories, C-clamp.
Now, let us see the procedure for the fillet lap weld by SMAW process. Cut the plate pieces by gas cutting and grind the gasket edges to square. Remove the grinding burrs and clean the surfaces. Set the pieces in the form of a lap joint as shown. Tack weld on both ends and ensure the two lapping surfaces are perfectly cleaned and they contact each other properly. Use a 2.5 mm MS electrode with 120 amp current for tacking. Set the lap joint in a flat position and remove the slag with a chipping hammer and clean the weld with a steel wire brush. Now, let us look at how to perform a fillet lap weld on a MS plate in a flat position by SMAW process. Deposit root run by using a 2.5 mm dia medium coated MS electrode with 100 to 110 amps current. De-slag and clean the root slag thoroughly. Ensure an electrode angle of 45 degrees with the fillet corner and 80 degrees with the welding line. Maintain a short arc to get uniform fusion and root penetration and avoid side-to-side movement of the electrode. Deposit the final covering run with a weave motion using 4 mm dia medium coated MS electrode with 150 to 160 amps welding current. Give side-to-side movement to the electrode not more than 2.5 times its dia. Prevent the upper edge of the plate from melting off by not allowing the arc to concentrate more on the upper edge. Clean the weld with a steel wire brush. Inspect the lap fillet weld for surface defects and size.
Recap.
Prepare plate pieces by gas cutting and by grinding to size. Set plates as a lap joint. Tack weld at both ends. Deposit root run of proper size and ensure penetration. Deposit the final covering run in the lap joint of proper leg size. Inspect the lap fillet weld for surface defects.
Let us learn about fillet welding now. Fillet welding refers to the process of joining two pieces of metal together when they are perpendicular or at an angle. These welds are commonly referred to as T-joints, which are two pieces of metal perpendicular to each other. Now, let us look at how to perform a fillet T-weld on a mild steel plate in flat position by SMAW process.
At the end of this exercise, you shall be able to set and tack plate pieces in alignment as T-joint and by keeping distortion allowance. Set the T-joint in flat position for welding. Deposit root run in T-joint of proper size and penetration. Deposit final covering run in the T-joint of proper leg size. Inspect surface defects on the fillet weld.
Now, let us look at the tools required for T-joint on a 10 mm thick MS plate. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine, C-clamp.
Let us see the procedure for the fillet T-joint on MS plate in flat position by SMAW process. Cut the plate by gas cutting. Clean the joining edges and surface of the plates and set the pieces in the form of T in alignment forming 90 degree between the plates. This presetting to 90 degree is done to compensate the effect of shrinkage forces when weld deposit cools down. Preset the pieces to have 90 degree angle between the plate surfaces and give a distortion allowance of 3 degrees. Tack weld the pieces at both ends of the T-joint by using a 2.5 mm dia medium coated MS electrode and 110 to 120 amps welding current. Deposit root run using 2.5 mm dia medium coated MS electrode and 110 amps welding current. Ensure uniform root penetration and an electrode angle of 45 degrees between the plates and 80 degrees with the weld line. Deslag and clean the root slag thoroughly. Deposit covering run with a weave motion using a 4 mm dia medium coated MS electrode and 160 amps welding current. Proceed along the welding line with uniform travel speed and short arc to get uniform fusion and root penetration. Use a weld gauge for checking the leg size of the weld. If you do not get the required 10 mm leg length in 2 runs of weld deposit, then deposit a third run using the same technique adopted for the second run. Stop the electrode weaving for a moment at the toes of the weld to avoid undercut. Fill the crater at the end of the bead. Here are some of the defects of fillet T-joints. Spatters, crack, parent metal, crater, trapped slag, underfill.
Recap.
Set the T-joint in flat position for welding. Set and tack plate pieces in alignment as T-joint. Deposit root run of proper size and penetration. Deposit final covering run in the T-joint of proper leg size. Inspect surface defects on the fillet weld.
Now, let us look at how to perform a corner joint weld on mild steel plate 10 mm thickness in flat position by SMAW process. At the end of this exercise, you shall be able to
set the plates to form an open corner joint at 90 degrees with specified root gap in flat position. Tack weld the pieces as an open corner joint at both ends. Deposit root run in the corner joint with the formation of a keyhole and obtain complete penetration. Deposit uniform covering layers in the corner joint using weaving of electrode and complete the weld. Inspect the welded joint for penetration, reinforcement and throat thickness.
Now, let us look at the tools required for corner joint on a 10 mm thick MS plate. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine, C-clamp.
Now, let us look at how to perform a corner joint weld on MS plate 10 mm thickness in flat position by SMAW process. Set the plates as an open corner joint on the table with parallel root gap of 2.5 mm throughout the joint. The angle between the plates is kept at 87 degrees to control the distortion. Another method to control distortion is to set the angle at 90 degrees and use a right angled iron fixture to minimize the distortion. Clean the tacks. Check alignment and reset the joint if required. Tack weld the corner joint from inside using a MS electrode 2.5 mm dia and 100 to 110 amps current range. Tack weld with maximum tack length of 20 mm each. Deslag and clean the tacks using chipping hammer and wire brush. Deposit root run in the bottom of the corner by using a MS electrode 2.5 mm dia and welding current of 110 to 120 amps, maintaining a slightly short arc. Position the electrode vertically between the edge and 60 to 70 degrees with the weld line. Form a keyhole near the weld crater of the tack weld to ensure complete penetration. Maintain travel speed similar to the speed used for straight beading. Clean the root run thoroughly and observe penetration. Ensure no slag particles are adhering on the root run. The crater is to be properly filled in each run. Deposit first covering layer, that is the second run, using 4 mm dia medium coated MS electrode and with 160 amps welding current. A weaving motion of the electrode has to be given to ensure enough metal is deposited in the groove and both edges of the plates are fused. Ensure that the electrode angles are as uniform medium arc length. Uniform normal travel speed should be maintained. Clean the slag from the first covering layer thoroughly. Ensure all the surface defects are rectified. Deposit second covering layer, that is the third run, using 4 mm MS electrode and 160 amps welding current. Use wider weaving motion to the sides of corner joint. A slower rate of travel than the first covering layer has to be followed. Use the same angle of electrode and arc length as used in first covering layer. Each movement of the weave from one side to the other will deposit more metal, and that takes more time. Ensure restarting and stopping of the beads correctly. The usual defect on the final layer of weld is edge plate melted off. This can be eliminated if care is taken to weave the electrode to the required extent so that the edges are just fused. The arc should not be focused on the edges at all. Let us do the inspection of fillet weld in the corner joint. Check each run for the following weld characteristics. The width and height of the weld has to be uniform. The appearance has to be smooth with close ripples. The face of the weld on root run and first covering layer should be flat. The final run layer has to be slightly convex. The edges of the welds has to be looked for good fusion, no undercut or no overlap. The start and stop of the weld has to be free of depression and high spots. The craters should be filled. The back side of the joint has to be complete and should have uniform penetration.
Recap.
Set the plates to form an open corner joint at 90 degrees. Tack weld the pieces as an open corner joint at both ends. Deposit root run in the corner joint with the formation of a keyhole and obtain complete penetration. Deposit uniform covering layers in the corner joint using weaving of electrode and complete the weld. Inspect the welded joint for penetration, reinforcement and throat thickness.
Hello students, welcome all for today's session. In this topic, you are going to learn about the welding process of open corner joint on mild steel sheet 2 mm thick in flat 1F position using gas metal arc welding GMAW process.
At the end of this topic, you will be able to cut the MS sheet as per size 150 mm length, 50 mm width and 2 mm thickness. Set the corner joint flat and tack weld the job. Deposit the root run. Inspect for surface defects on the weld. Let's see the tools required for the welding process. Steel rule, ball peen hammer, half round file, tri-square, tongs, chipping hammer, steel wire brush, personal safety equipment, key and spanner, helmet type screen, angle grinder, gas regulator with flow meter, CO2 gas heater, shielding gas hoses, welding power source, wire feeders, supply of electrode wire, welding gun, shielding gas cylinder. We will now examine the pre-welding preparations for open corner joint on an MS sheet 2 mm thick in flat position using gas metal arc welding process. Wear protective clothing. Cut the mild steel sheet as per size 150 mm length, 50 mm width and 2 mm thickness. Clean the surface of the sheets by carbon steel wire brush and filing. Set both plates in the shape of a corner joint at 90 degrees in flat position. Set the root gap to 1.5 mm. Connect the torch and adjust the current to 90 to 100 amps. Corresponding wire feeding rate 3 to 4 mm per minute. Set arc voltage as manufacturer specification. Use 0.8 mm dia, copper coated, mild steel filler wire. Corner joint tack weld on both ends and at the proper spacing. Check the corner joint alignment for 90-degree angle with a tri-square. Let us now look at how to do the welding process for an open corner joint on an MS sheet 2 mm thick in flat position using gas metal arc welding process. Keep the tack welded job in flat position on the welding table. The gun is held perpendicular to the joint at an angle of 5 to 15 degrees forward to the direction of travel. Deposit the root run in the joint by forming a keyhole. Use weaving technique for the deposition of weld bead. Ensure the edges of the plate are not melted off due to excessive weaving. Deposit the second run if needed. The torch movement at the edge of the top sheet of the corner joint should be regulated to avoid melting the edge. The torch has to be paused when reaching the end of the weld. Finally, if a crater forms, it must be appropriately filled with filler metal. Maintain a uniform travel speed for the torch to get the required bead reinforcement, height, and appearance. Use the anti-spatter spray as and when the torch nozzle gets clogged with weld spatters. Uneven flow of CO2 gas can cause air contamination and porosity. Clean the bead with a steel wire brush. Inspect the welded joint for any surface defects. There are some important points to be followed for open corner joint on an MS sheet 2 mm thick in flat position using the GMAW process. Maintain a uniform travel speed for the torch to get the required bead appearance. Ensure good leg length and even fusion of plates. Let us inspect the open corner joint now. Spatters. Blowholes. Uneven bead formation. Distortion. Porosity. Edge of the plate melted off.
Recap. Let us do a quick recap of what you have learned from this topic. Cutting the MS sheet as per size 150 mm length, 50 mm width and 2 mm thickness. Set the corner joint and tack weld the job. Deposit the root run in flat position. Inspect for surface defects on the weld. Thank you students. Let us now meet in the next session. Bye-bye. Hello students, welcome to a brand new topic. Today in this topic we are going to learn about fillet lap joint on MS plate 12 mm thick in flat position using gas metal arc welding process.
At the end of this topic, you will be able to prepare MS plates as per size 150 mm length, 50 mm width and 12 mm thickness. Set the MS plate in flat position as a lap joint and tack weld. Deposit the fillet weld with proper leg length. Inspect for surface defects on the weld bead. Let us now take a look at the tools required for fabrication of fillet lap joint on an MS plate 12 mm thick in flat position using gas metal arc welding process. Steel rule. Ball peen hammer. Half round file. Tri-square. Tongs. Chipping hammer. Steel wire brush. Personal safety equipment. Key and spanner. And spanner. Helmet type screen. Angle grinder. Gas regulator with flow meter. CO2 gas heater. Shielding gas hoses. Welding power source. Wire feeders. Supply of electrode wire. Welding gun. Shielding gas cylinder. We will now examine the pre-welding preparations for the fillet lap joint on an MS plate 12 mm thick in flat position. Wear protective clothing. Cut the MS plate 150 mm by 50 mm by 12 mm as per drawing. Square the plate's edges by grinding and filing them. MS plates should be deburred and cleaned. Set the lap as per specification. Wear protective clothing. Set the torch in the right position. Set the current to 90 to 100 amps. Feeding rate of the corresponding wire 3 to 4 mm per minute. Set arc voltage as per manufacturer specification. Use 1.2 mm dia copper coated mild steel filler CCMS wire. On the welding table, tack weld both ends of the lap joint. Go through the welding process for fabrication of fillet lap joint on an MS plate 12 mm thick in flat position. Keep the tack welded job in flat position on a welding table. The gun is held at an angle perpendicular to the joint of 5 to 15 degrees forward to the direction of travel. Deposit the root run using dip transfer mode. Use stringer bead welding technique. Deposit the second run. The torch movement at the edge of the top sheet of the lap joint should be regulated to avoid melting the edge. When the torch reaches the bottom toe of the weld, it must be delayed for a short length of time so that the undercut, if it develops at the toe, is correctly filled with filler metal. Deposit the third run. Maintain a uniform travel speed for the torch to get the required bead reinforcement, height and appearance. Use the anti-spatter spray as in when the torch nozzle gets clogged with weld spatters. Clean the bead with a steel wire brush. Inspect the welded joint for any surface defects. There are some important points to be followed for a fillet lap joint on an MS plate 12 mm thick in flat position using gas metal arc welding process. Use the anti-spatter spray as in when the torch nozzle gets clogged with weld spatters. Note that if this is not done, the wire feed may be irregular, causing an unstabilized arc, and the CO2 gas flow will not be uniform, causing atmospheric contamination of the weld and porosity. Ensure the edge of the plate A at the toe of the weld is not melted off due to the excessive weaving. Ensure there is no undercut at the other toe of the lap weld. Let us inspect the lap joint now. Edge plates melted off. Excessive reinforcement. Undercut. Porosity. Uneven bead width. Blowholes.
Let us do a quick recap of what we have learned in this topic. Fillet lap joint on MS plate 12 mm thick in flat position using gas metal arc welding process. Prepare the MS plates as per size 150 mm length, 50 mm width and 12 mm thickness. Tack weld. Weld the MS plate in a flat position as a lap joint. Place the fillet weld with the proper leg length. Inspect for service defects on the weld bead. Thank you, students. Let us now meet in the next session. Hello students, welcome all for today's session. In this topic, you are going to learn about the silver brazing on SS sheet with copper sheet, T-joint in flat 1F position using oxy-acetylene welding OAW process.
At the end of this topic, you will be able to prepare stainless steel and copper sheets as per size 150 mm length, 50 mm width and 2 mm thickness. Set the T-joint in flat position for silver brazing. Deposit the bead with appropriate amount of filler metal. Inspect the T-joint for any surface defects. Let us now take a look at the tools required for silver brazing on SS sheet with copper sheet T-joint 1F using oxy-acetylene welding process. Steel rule. Center punch. Ball peen hammer. Angle grinder. Half round file. Bench vise. Tri-square. Chipping hammer. Steel wire brush. Safety clothing. Gloves. PPE kit. Nozzle number 7. CCMS filler rod 3 mm. OAW setup. Cylinder key. Tip cleaner. Spark lighter. Gas welding goggles. Now let us look at the pre-welding preparations for the silver brazing on SS sheet with copper sheet T-joint 1F using oxy-acetylene welding process. Wear protective clothing. Cut the stainless steel sheet 150 mm length, 50 mm width and 2 mm thickness by using shearing, grinding and filing. Cut the copper sheet 150 mm length, 50 mm width, 2 mm thickness by using shearing, grinding and filing. Clean the base metal with a steel wire brush. Set the SS sheet as base metal. Along the length, keep the copper sheet perpendicular to the SS sheet. Set the sheets as T-joint on the welding table. Open the cylinder valves, both oxygen and acetylene, slowly. Set the working pressure. Select nozzle, 1 or 2 size bigger than the sheet thickness. Select 1.6 mm dia filler rod with 40 to 50% silver and 15 to 25% to 15% zinc remaining copper. Ignite the flame with a spark lighter. Set slightly oxidizing flame. Tack the job at each end of the sheet. We shall take a look at the welding process For the silver brazing on SS sheet with copper sheet T-joint 1F using oxyacetylene welding process. Place the tack joint in flat position on a welding positioner. Start brazing at the right hand end of the joint by fusing the tack weld. Keep the blowpipe in the leftward direction at an angle of 60 to 70 degrees and filler rod at an angle of 30 to 40 degrees to the line of travel. The blowpipe and filler rod should be held at a 45-degree angle between the joint's two sides. This will ensure root penetration. Apply silver brazing alloy to the joint, making sure it flows evenly into the joint. Watch the molten metal closely to make sure that both the pieces are joined by brazing. When the molten pool is formed, add the filler rod in the center of the molten pool. Allow the blowpipe to move slightly side to side. Apply a piston-like movement to the filler rod. Adjust the rate of travel of the blowpipe and the filler rod to secure even penetration at the root and into both sheets. By doing that, it will produce a fillet weld of equal leg length. Clean the bead with a steel wire brush. Inspect the weld for any surface defects. Now we will look at the important points to be followed for square butt joint on MS sheet 2 mm thick in vertical position using the OAW process. Use tongs to remove the job from the fixture. Inspect the surface defects and root penetration. Let us now see the defects. Uniform weld size. Excess reinforcement. Leg length. Porosity. Blowholes.
Let us do a quick recap of what we have learned in this topic. Prepare stainless steel SS and copper plates as per size 150 mm length, 50 mm width and 2 mm thickness. Set the T-joint in flat position for silver brazing. Deposit the bead with appropriate amount of filler metal. Inspect the T-joint for any surface defects. Thank you, students. Let us meet in the next session. Hello students, welcome for today's session. In this topic, you are going to learn about open corner joint on MS plates 10 mm thick in flat position using gas metal arc welding.
At the end of this exercise, you shall be able to prepare MS plates 150 mm length, 50 mm width and 10 mm thickness. Set the corner joint in flat position and tack weld the plates. Deposit the weld bead with uniform travel speed. Inspect for surface defects on the weld. Let's see the tools required for the welding process. Steel rule, ball peen hammer, half round file, tri-square, tongs, chipping hammer, steel wire brush, personal safety equipment, key and spanner, helmet type screen, angle grinder, gas regulator with flow meter, CO2 gas heater, welding power source, wire feeders that ensure constant speed and voltage, supply of electrode wire, welding gun, shielding gas cylinder. Go through the pre-welding preparations for the open corner joint on an MS plate 10 mm thick in flat position using GMAW process. Wear protective clothing. Cut the MS plates 150 mm length, 50 mm width and 10 mm thickness as per drawing. Filing is used to deburr and clean the MS plates. Grind and file the edges of plate to square. Set the plates in the form of a corner joint in a flat position. Place the torch in the proper place. Set current to 90 to 100 amps. Appropriate wire feeding rate 3 to 4 mm per minute. Set the arc voltage and select the dip transfer mode. Use 1.2 mm dia copper coated mild steel filler CCMS wire. While tack welding plates for the corner joint, the angle between them is to be kept at 90 degrees. Tack weld on both ends of the corner joint. Maintain 10 mm tack size on either side. Let us now go through the welding process for the open corner joint on an MS plate 10 mm thick in flat position using GMAW process. Maintain the tack welded job flat on a welding table. Deposit the weld using uniform travel speed. Deposit root run by maintaining a keyhole for fine penetration. Clean the root run by wire brush. Deposit the second run using a stringer bead. Ensure good penetration and even fusion of plates with suitable torch angle and arc travel. Clean weld bead with steel wire brush. Ensure good penetration and even fusion of plates with suitable torch angle and arc travel. Deposit the third run using stringer bead. Clean the bead with steel wire brush. Inspect the bead for any surface defects. There are some important points to be followed for open corner joints on an MS plate 10 mm thick in flat position using the GMAW process. Wear protective clothing. Use the anti-spatter spray as and when the torch nozzle gets clogged with weld spatters. Note that if this is not done, the wire feed may be irregular, causing an unestablished arc. The carbon dioxide gas flow will not be uniform, causing atmospheric contamination of the weld and porosity. Inspect the welds for uniformity and sufficient reinforcement. Clean the welded area. Inspect for welding defects. Let us inspect the joints now. Overlap. Undercut. Lack of root penetration. Spatters. Blowholes. Excess reinforcement. Slag inclusion.
Let us do a quick recap of what we have learnt from this topic. Prepare mild steel plates to size 150 mm length, 50 mm width and 10 mm thickness. Set the corner joint in flat position. Tack weld the plates. Deposit the weld bead with uniform travel speed. Inspect for surface defects on the weld. Thank you, students. Let us meet in the next session. Bye-bye.
Now, let us look at how to perform a single V butt joint weld on mild steel plate 10 mm thickness in flat position by SMAW process.
At the end of this exercise, you shall be able to bevel the plate edges by gas cutting for single V butt joint. Grind the gasket bevel edges with proper root face for single V butt joint. Set the plates with a root gap of 2 mm and proper distortion allowance. Deposit root run in single V butt joint to ensure complete penetration. Deposit intermediate and final covering runs to obtain proper fusion and reinforcement. You will also be able to inspect the groove weld for surface defects and uniform root penetration.
Now, let us look at the tools required for single V-butt joint. Steel rule, scriber, prick punch, ball peen hammer, flat file, bench vise, tri-square, tongs, chipping hammer, steel wire brush, electrode cable and earth cable, electrode holder, electrode, personal protective equipment, SMAW welding plant machine, C-clamp.
Let us see the procedure for the single V butt joint on MS plate 10 mm thickness in flat position by SMAW process. Straight cut 2 10 mm thick plates by gas cutting as per drawing and grind them to size. Bevel the edges of each plate to 30° angle by gas cutting. And file the root face as per drawing and cutting the bevel. Clean the plates from dirt, water, oil, grease, paint and keep the plates inverted in the form of a butt joint with proper root gap. Maintain a distortion allowance of 1.5 degrees on each side of the joint. Use a 2.5 mm medium coated MS electrode and set to 110 amps current. In the case of a DC welding machine, connect the electrode cable. Tack weld on the back side of the plates at the ends. The length of the tack should be 5 to 10 mm. Deslag the tack weld and clean. Position the tack welded job on the table in flat position, the single V portion facing up. Deposit the root run and fill the crater and take special care to maintain the keyhole. To ensure proper melting of root face and root penetration. Deposit the second or intermittent run using 4 mm dia medium coated electrode and with 150 to 160 amp current. Maintain short arc and proper weaving of the electrode. Avoid excessive weaving and ensure normal travel speed. Fill the crater wherever necessary and deslag. Deposit the third or covering run using the same parameter and technique used for the second run. Ensure a proper reinforcement of 1 to 1.5 mm and avoid undercut. Inspect for any surface weld defect. Now, let us see the common defects of the SMAW process. A groove or channel formed in the parent metal at the toe of the weld is called undercut. An overlap occurs when the molten metal from the electrode flows over the parent metal surface without fusing into it. Blowhole or gas pocket is a large diameter hole inside a bead or on the surface of the weld caused by gas entrapment. Small metal particles which are thrown out of the arc during welding along the weld and adhering to the base metal surface is called spatter. Failure of weld metal to reach and fuse the root of the joint is called incomplete penetration. Slag or other non-metallic foreign materials entrapped in a weld is called slag inclusion.
Recap.
Bevel the plate edges by gas cutting for single V butt joint. Grind the gasket bevel edges with proper root face for single V butt joint. Set the plates with a root gap of 2 mm and proper distortion allowance. Deposit root run in single V butt joint to ensure complete penetration. Deposit intermediate and final covering runs to obtain proper fusion and reinforcement. Inspect the groove weld for surface defects and uniform root penetration.
Hello viewers, welcome to DG Shala. I am Anuradha, Assistant Professor, National Institute of Rural Development, Panchayati Raj. Today we will be discussing about